kind of troll, that's also not a debate. But a real debate.
Pretty genuine, at least as far as your answers go to these kind of questions. As far as I can tell, would it ever be possible if a jet plane that had like the capabilities of flying 1,000 miles per hour and like 40,000 pounds of thrust, and like the best jet plane you could find, if it has a dead reckoning north or south for over a period of like maybe 1,000 miles, would it ever be able to pick up with the camera that has really great quality and zoom in capabilities? Would it ever be able to pick up a west to east Earth movement underneath it to show the Coriolis effect?
No, yeah, we've talked about this a time or two. I mean, I've been present when we were talking about it.
Yeah, I haven't heard your answer to it.
Yeah, I don't think so, because the atmosphere, in our model is moving with the Earth. The plane is going to be subject to that in the way of a crosswind, and it would just be a gradual, motion that it would basically stay with the velocity of the.
Show us that model.
Hold on, wait just a second. Let me continue.
Show us that. Don't give me a hypothetical. Show me the model of how the atmosphere is moving with the Earth. Because you're
regardless of that point, even if we give you that point, what I'm trying to get to is the idea that a jet plane that can fly 1,000 miles per hour and have all these, resistant forces to winds and fly against the spin and fly with the spin and fly in circles if it wants to, go into the jet stream, pop out of the jet stream, all of these different variations with an original conserved speed that doesn't match the tangential speeds of the latitudes that it's flying into. To argue that the plane would be so forced by this atmosphere with winds in all different directions to only see a stationary Earth below it seems a little bit like a stretch, and like it has to be that way because the model's broken if it doesn't work that way. It seems like it seems like it.
It appears that it's like a 1 mile per hour crosswind, a 1.25 mile per hour crosswind on a commercial airliner. So I mean, it is subtle.
Yeah, it's minute. You're more concerned about weather, wind, just regular wind, than you are the Coriolis effect.
I understand that. I'm not asking. Wait. I want to clarify this position.
You just said that the atmosphere and the Earth are spinning together.
Regardless of all those arguments, let's just say the atmosphere does go with the Earth like they want it to happen, right? Let's say all of those conditions are perfect in the way they want. It still doesn't stand to reason that a plane with the flying capabilities of this jet airplane that can do pretty much whatever it wants in the air, it's not bound by the winds, and the winds correcting it perfectly to only always see a motionless Earth below doesn't add up, because it has a different conserved speed. It's flying over different tangential speeds. It's already above the ground, so it wouldn't even conserve the speed that it had at the ground, because it has a greater circle, it has a greater circumference. It's not in sync automatically as soon as it goes in the air. You can say it's minimal. You can say it's negligible. I'm just saying, is there any way that with the best cameras on this plane that it could ever catch just a hint of a west to east rotating Earth?
It would appear as actually 1,000 miles an hour would appear as like a 2.4, 2.5 mile per hour crosswind. How are you going to see this? What are you looking?
I'm not asking how am I going to see it. I'm asking if there's ever a situation where a plane that does dead reckoning.
If we can eliminate weather,
west to east rotation.
Hold on, guys.
Is there a scenario you could think of? Let's say the jet plane was able to overcome those forces, right? And it was able to do a perfect dead reckoning straight up and down, north and south, right?
Yeah.
Would it see a rotation of Earth underneath?
No, it wouldn't.
That's what the Coriolis effect is, right?
No, it wouldn't.
So it can't mimic a projectile.
Have you seen a jet airplane landing on a runway in a crosswind? Have you seen footage of that?
I'm not asking about those scenarios. I'm just asking if
that is the scenario.
If it's
the Coriolis force is much less than that.
I'm not even asking you if it's
a breeze is far stronger.
I'm not asking about how minimal you can make it. All I'm asking you
right now, this is not going to go good.
If it's a dead reckoning, is it ever
possible
is less for a plane to capture? Rumpus.
Moderator talking. Moderator.
Listen,
moderator.
Yeah.
Talking.
Listen, this is not going to go good. Rumpus. I'm telling you right now, I'm not playing this game with you guys. Just
Okay,
don't
well,
overtalk each other and go one at a time.
Well, he's been
please.
talking constantly, and
I know. Let him finish, and then you're going to go. We're going to let him finish, and then you go.
You guys are going to come up with all of these reasons why it would be.
Were you talking that whole time?
I'm sorry.
He was.
It doesn't matter. No one else heard you, but go ahead. Go. And
okay, I just want to clarify. Yeah, I just want to clarify because they'll say it's all about the crosswinds. It's going to make it seem like it's not very much of a difference. But the whole idea of a Coriolis effect is there's west to east movement of a rotating Earth underneath the plane, which would cause it to be off course if it didn't correct the Coriolis. You can say it's minimal. You can say
They cannot say that.
Would make it seem like the Earth is stationary. I'm just asking, can you think of any scenario where a plane?
But they cannot say that. They just said
going north or
the
south
air moves with the Earth.
rotating Earth.
George, wait.
Is there ever a situation you could think of where a plane with the best and most amazing capabilities, with cameras underneath the plane showing the Earth, right, with the best capabilities of this plane, could it ever show any movement of west to east?
What would you?
I'm not expecting anything wrong.
If it was in a crosswind,
you could think of a scenario.
You gotta let him. Hold on a second. You gotta let him respond. New perspective. You gotta let him respond, bro.
He's jumping on a point I'm not even making.
Going to go on for?
It's fine. Let him say his response. Hold on, Rumpus.
He's made the same point 17 times.
I'm trying to clear the floor for you.
Well, how about me having a go?
I'm trying to clear the floor for you.
You're misunderstanding it.
I'm just going to mute you. I'm just going to have to mute you guys.
Seriously,
I'm trying to clear the floor for Rumpus. He's not letting me do that. You're talking all over me at the same time. New perspective. Come on, guys.
I'm sorry.
Right, number one, the Coriolis has got nothing to do with the crosswind and the tangential thing. You don't understand what Coriolis is. That's just simply the crosswind, the velocity of the air, the atmosphere, moving with the Earth has got nothing to do with Coriolis. And as we know, 1,000 miles an hour at the equator, 0 at the poles, and there's a graduation between the two. Now, if anybody has seen an aeroplane fighting with a sort of 20-mile-an-hour crosswind on a runway, can clearly see what 20 miles an hour does. A plane has to point at it, not quite 20, 30 degrees to keep going in a straight line. Now, just imagine if there was a 2-mile-an-hour breeze that it was subjected to for the length of time that it takes to get from the North Pole to the equator. It only requires I think I worked it out that the acceleration is much less than you get than a snail. The velocity that it has to go by is less than a snail has to cover. A breeze is far more important, far more effective in terms of changing the angle of an aeroplane than the effect of the change in the velocity of the atmosphere.
Coriolis.
No idea what you're talking about.
Okay.
That is double speak. He's double speaking.
Completely irrelevant to what I just pointed out.
Hold on. This is what I took away from that. The thing you got to worry about are crosswinds and breezes and air currents and blah, blah, blah. Okay, yeah, we all know about that. The thing you said was the least common denominator was Coriolis. So
no idea what you mean by that.
Fuck out, and guess what you don't have anymore? Guess what you don't have anymore? You don't have Coriolis.
It's something to do with Coriolis. The speed of the atmosphere moving with the rotating Earth has got nothing to do with Coriolis. You do not understand what Coriolis is. Coriolis is the force that's related to, you have to have a velocity, and then there's a small force. People like Nathan Oakley think it's something to do, there's 1,000 miles an hour. Okay, if you're moving at 1,000 miles an hour with the Earth, there is no Coriolis effect. If you're stationary with respect to the Earth, there is no Coriolis force.
Nathan is not here.
Okay, well, you're just parroting what he says.
Rumpus, I don't think you understood my question, though, because I didn't ask if it would be effective. I didn't ask if it would be minimal. I didn't ask if it could be ignored. I didn't ask any of those questions. I asked if you could think of a scenario where a jet plane that has all the capabilities in the world could ever fly north or south and see nothing but a stationary Earth. Would the plane be bound to only seeing a stationary Earth? That's my question.
With Coriolis, it's all to do with the atmosphere's velocity, and that's got nothing to do with Coriolis. And the velocity of the atmosphere matches the surface of the Earth, and that's got nothing to do with Coriolis.
It's not his question, though.
That's not my question. I'm just asking yes or no.
He's asking a question about
Coriolis. Yes or no question.
And he's describing
a yes or no question.
Describing a question that has nothing to do with Coriolis.
Okay, great. Wait, hold on. Please. Okay, Rumpus, give us a scenario where it has everything to do with Coriolis.
If you fire a shell or something which has a velocity, remember, Coriolis is dependent on the velocity and what you won't understand what I'm about to say, the cross product with the axis of the angular velocity. Now, that means that you need to see an effect of Coriolis, you need something that's moving moderately quickly, say more than 50 odd something miles an hour, and you need it to happen over a long period of time before you will see an effect. If it's not moving quickly and it's not over a long period of time, then you will not see an effect. So something like a shell, for instance, in a battle, they have to travel for a minute. They have to travel.
Let me clarify. Okay, let me just clarify what you said, Rumpus. So wait,
hold on. So what you just said negated everything. If you have something moving at an extremely fast speed and over a long distance, both those things negate each other.
You've no idea what Coriolis is.
Wait, Copernicus, let me just clarify this point real quick, because okay, let me just ask you this, yes or no, Rumpus. Is the Coriolis, when you're talking about a projectile that's moving very fast and it's very small, right? The reason that we talk about Coriolis effect is that the Earth is rotating underneath a straight path of a projectile, correct? Yes or no?
If it's not affected by the atmosphere, if an airplane's affected by the atmosphere, which is rotating, but if you fire a shell, which is not affected so much by the atmosphere, then it is trying to go in a straight line, then you have a velocity with respect to the reference frame of the rotating Earth, and then you do get a Coriolis effect if it goes on for something like a minute with an artillery shell, for instance.
So your answer is yes.
I've forgotten now what your question was. I was just describing.
Yeah, can you just answer yes or no, please? Could you answer yes or no to the question? Don't go on about it. Just yes or no, please.
Here's a short answer. If you could put a camera, on an artillery shell, you would see a little bit of what you're talking about.
Okay, that's what I'm asking. So you're saying that if you could put a camera on an artillery shell that's moving in a straight path, north or south, what the camera would see is at least a little bit of Earth.
If you saw the Coriolis effect, you would have to know where you would arrive. That's when you fired a shell, for instance, 20 miles away, and you were a battleship, and you were firing a shell at another battleship 20 miles away. If I put a camera on that shell, you wouldn't be able to tell any difference whether it's the Coriolis what the Coriolis effect is or not. All you would simply see is the path of the shell.
That's not my question.
You'd have to know where the shell would arrive if you didn't allow for Coriolis or not. You wouldn't be able to see that difference from the pictures.
Rick, I didn't ask if you would be able to or if you'd be able to tell. I'm just asking, and it was clarified. Thank you very much, Left Lane. So Left Lane's confirming that if you were able to have a great camera on this shell, that you would be able to see west to east Earth movement.
No, you
underneath.
Wouldn't.
Well, that's what the Coriolis effect is.
If you fired a shell anyway, and you just fired it east to west, you'll see it going east to west. All you're talking about is monitoring the trajectory of the shell. You wouldn't be able to tell there's Coriolis going on.
I'm not asking if you can tell. I'm not asking.
Well, what are you asking then? There's no Coriolis effect on the pictures. There's nothing that looks Coriolis-y on the pictures.
I'm just clarifying the point.
There is nothing that looks like Coriolis on the pictures.
You're getting all upset.
Just as you can't see the wind effect either.
I don't know who talked over who, but you guys were talking completely at the same time.
Yeah.
So
just end up shouting at each other. Yeah, I just want to put in, just give me 10 seconds. Throughout the last half an hour, I've heard everyone talking about the atmosphere rotating with the Earth, and it's just taken in these conversations as a given. I'm telling you, anyone who thinks that the atmosphere is spinning around with the Earth, you are either ignorant or you are certifiably insane. A rock spinning.
You're a science denier then.
No, that's correct. That's correct. It's a fact that gas does not move with a solid like that. You can't get gas.
Have you been near a sand? Have you been near rotating sand?
Rumpus, I'll mute you. Don't talk over me. Don't talk. You want to talk out of your textbook? Oh, good luck to you. I'm telling you, I work with this stuff.
Have you been near a sander belt?
Rumpus.
Have you been near a sander belt?
I don't want to mute you, Rumpus, but I will. Let me say 3 sentences and then you can respond, okay?
Okay.
I work with this stuff all day, every day.
What stuff?
I repeat, if you think a spinning rock is going to drag gas around with it in lockstep, you are either ignorant of the reality of our world or you are certifiably insane.
You've had 3 sentences. Right. If you have a
And now
belt
I'll
sander,
mute you.
you've had 3 sentences, and you had more than that, in fact. So it's my turn. And
Listen,
half of
buddy,
it was an ad hom anyway. It wasn't actually to the point.
monologuing twit.
Yeah, no, you were the one who's monologuing.
You were the
and
last
you
person,
you didn't
Rumpus,
actually
honestly,
make a point.
you're the last
You
person
didn't
to
make
be
a point.
having
You
this
didn't make a
criticism of
point,
anybody.
and I'm trying to give you a real point for you to think about that you will be able to understand. If you've been near a sander, for instance, on a sanding belt on something, and if you get to the far end of it, you will see there's a breeze. And similarly, with the wind in a car, you can feel that when you're going along, do you not think that your hand from sticking out of the wind is deflecting the wind? And similarly, that's what the Earth does. And you've got to bear in mind, and you see interrupting me, and you've also got to bear in mind, you've got to bear in mind that the space does not in any way.
Let him go, and then I'll respond. Let him go, and I'll respond.
So when the Earth rotates, there's nothing to stop the air. There's no frictional forces. Whereas something like the situation I described with a sanding belt in a workshop, there is air above it that's going to slow it down, and there's air above that that's also going to slow it down. But space doesn't do that. There is nothing to slow it down. So once air starts moving in a direction, the rest of the air above that will gradually pick it up. I mean, think of a smoke. If I was to blow out a vacuum, a jet of air, and you put it in a smoke chamber, you would see the smoke being dragged along by a fan, for instance. And there you have an example of air dragging along other air, and that's exactly what happens in the atmosphere. Go ahead.
Oh God, that's hilarious. So, okay, now you just said yourself. You just said yourself with your sanding belt, the air above it will slow it down and stop it. So that's this alleged breeze you're talking about from the sanding belt.
Yeah, if you've got something that's constantly going, it will speed it up.
Do you have Tourette's? Can you possibly stop talking?
Are you going to listen to what I said?
Rumpus, I know you don't like to be. Yeah, Rumpus, you don't like to be muted. The problem is you can't let anyone speak without snipping and clipping and doing things. So I guess what we'll have to do with you is temporarily mute you every single time you're done speaking, so others can speak. Go ahead, Effie.
Thanks, Gio. Okay, so you yourself, from your own mouth, said that the air just above the sanding belt will slow down the air that's being moved by the sanding belt. Now, this is happening maybe 2 centimeters or 1 inch above the sanding belt, but you want to now assert that going up 30, 40, 50 miles from the surface of the Earth, it all manages to travel along in lockstep. First point of insanity. Second point. Once again, I'll reiterate, I work with this stuff, this in concept every single day, and it doesn't happen in the real world. You can talk your stupid little thought experiments all day long. I do this stuff all day long with my hands in the real world, and I can assure you it doesn't and won't happen. If you can show me that it does happen in any kind of scale model that's provable, then we'll have another discussion. I can show you that it doesn't happen. The onus is on you to show me that it does happen. Please go ahead.
Before you unmute Rumpus, can I add to that real quick? First of all, Effie,
you dropped out already.
Okay, good. What is it that you do that you work with your hands on every day that deals with this?
Can I just point out? Hold on 1 second. 1 second, Effie. Effie, 1 second. I just want to point out that if Rumpus can't interrupt and disrupt the conversation and make it so that nobody can get any point across clearly, he'll just disengage and leave the conversation. That's his whole game. Anyways, go ahead.
That's his name.
Oh, is he gone? Has he?
Yeah, he left because he can't work.
Okay. All right. I work with fluids and dissolving solids into fluids. So I work with, loosely you call it fluid dynamics. I in tanks with propellers and impellers, and I know how fluids react. I'll put a 1500 RPM impeller into a tank that's only 1 meter wide, and I can let it run for 3 hours, and the fluid speed within that tank will never get above 30 RPM, 40 RPM, even though this thing's going at 1500 RPM, and it's only got a 1 meter body of water that it's trying to spin. So I'm telling you, it's absolute fecking nonsense, this claim that gas, which has less intermolecular bonds than fluid does, is going to be sticking and rotating to a rock. It's insanity. It's honestly insanity. I don't know how else to put it.
Could I respond to that real quick?
Gases are indeed fluid. I only have 2 comments to make very quickly. The gases indeed are fluids also, regardless. And also, I was curious, whenever, of course, perspective is done, I was curious if you work with ferrofluids at all. Ferrofluids. But go ahead.
No, I don't, to answer the question quickly.
Okay, so
I'm just curious.
My hold on real quick. My point in bringing this up is that I think that if you can talk to a baller and get them to at least admit what we're talking about when we talk about projectiles and Coriolis, is they're saying that the projectile is moving so fast over a distance north to south that the Earth is literally moving independently of the bullet, causing it to diffract, right? That is what the Coriolis, just so we're all clear, that is what the Coriolis effect is. It's not about the winds, it's about the movement of the Earth up below the projectile. Okay, so what is it then? Explain it.
I agree with you, but it's got nothing to do with the speed of the projectile. The speed of the ballistic, whatever, it doesn't matter. That's irrelevant.
Kosho, can I ask you a question real quick?
Yeah, sure, man. We haven't spoken in a while. Sure, go ahead, sir.
What is your understanding of the original Coriolis observation?
The original Coriolis observation? Like Coriolis the dude?
No, like what he did in his observation that is now the topic that we're discussing. What was it he observed? What was it he tested? What was it he controlled? What was it he manipulated?
Hey, hold on, wait. I think you're getting off point a little bit, Copernicus, real quick, because he did agree with what I said. You said that the speed doesn't matter. What I'm trying to clarify is, you're saying that the Coriolis is caused from the Earth rotating underneath independently of the projectile, correct or not correct?
Sorry, yeah. No, I agree with that part. That the
okay, that's all I want to know. Wait, stop there. The projectile is moving independently north to south, and the west to east rotation is underneath. Yeah. Okay, go ahead.
I just want to make it clear what I was agreeing with. Yeah, okay, it's moving north to south, independently of. It's moving across rotating bodies, but it's doing. It's not. It's yeah.
So the Earth is moving independently of the projectile that's going north or south, and it's west to east. And if there could be an awesome camera that somehow shows the slow-mo of this, and it has the best frame rate, and it would show a Earth rotating west to east underneath, independently of the projectile moving north or south. Correct?
Yeah. If we had a camera, you said.
Yeah. Right. And if you had a plane with dead reckoning and it wasn't affected by any winds or all those things that you're talking about, it would very easily show a west to east rotating Earth underneath a plane that's going north or south, correct?
Yeah, if you had a plane or some sort of object that wasn't affected by the winds.
Yeah.
Yeah, if you had a grid system on the ground that could show the ground's grid system, then yeah, sure.
Well, you could just show the Earth moving, right? West to east underneath a plane that has a camera underneath it. If it had no winds or whatever. Now, what I'm saying is, even if we give them the conservation of momentum at the latitude it starts at, and then you do a straight path with a plane as dead reckoning as it can go, you can minimalize it all you want and say that the winds would cause it to slow down to the speed approximately of the Earth somehow, if that even worked, if that even was possible. But you can't say it's ever perfect. So therefore, the plane could falsify the model just by going north to south with a camera underneath showing a west to east rotating Earth.
Yeah, but you gave a hypothetical plane, and planes in real life are affected by the air because that's how they work.
Well, yeah, but there's planes that can defy the air, fly against the air, have lots of thrust in opposite direction, and go dead reckoning. So it's not perfect. You could detect something. And my conclusion is the only reason that a plane only ever sees a stationary Earth, the only reason that could ever be true always is that the Earth is stationary. If it wasn't stationary,
can I jump
you
in
would be able to detect this.
New perspective. Can I jump in real quick? You and I can talk to each other, I think. Okay, so let me ask you the same question I asked Kosho. What do you understand to be the primary demonstration of Coriolis's science? Like, let's go back to the guy himself. Like, what did he observe specifically?
It's just the rotation, the straight path. There's two things we're talking about. I think it gets really confusing on both ends of this discussion. And it doesn't get clarified that it's not just an apparent deflection that you would see from a third person perspective, right? Where you would see the straight path as opposed to a curved path, because if you're on the rotating device, it's going to be curved, right? But it's also the actual deflection, right? The path, if you're on a rotating device and you're trying to go straight, and the device is rotating, your path is going to be curved, even though you are going straight. But in relation to the curved surface or the rotating surface, it's going to be a curved path because the surface is rotating.
Okay, so
right?
Let me jump in.
Even though the plane goes straight.
Right. Okay. Well, yeah. So what I hear you doing is mixing two metaphors, so to speak, at the same time, and I know that I'm being abstract. I think that you're on to the correct answer in that, from my understanding, Coriolis was observing something that happened physically on a rotating surface. He has a rotating surface. He has an object moving across that surface. Okay? I don't have any problem with the physics you want to derive from that. The minute you move, the minute you move away from that and go into the air, you're not talking about the same thing anymore.
Okay, but let me just clarify for you. I think that you might be misunderstanding it then, because what the Coriolis effect is with airplanes and the Earth rotating is that if a plane were able to go dead reckoning north or south, right, with a rotating Earth underneath it, because it's no longer on the surface, it's in its own reference frame. Okay, if it were able to go straight and not be affected by any winds, then therefore the Earth moving below it would cause it to be off course.
Yeah, but it has nothing to do with it being not on the ground.
Okay, yeah, you're right.
Guys,
it does have something to do with being in the air, though, because it has a separate reference frame.
Oh my God! Listen.
No.
Listen. Again, we're talking about the very first thing Coriolis did. The very first thing Coriolis did, according to what I've looked into, he had a physical surface that he manipulated and rolled across another object in physical contact with that.
Yeah, of course.
Okay, great. That is as far as Coriolis goes. The minute you leave the surface of your rotating object.
Why are you talking slowly?
Because I want you to pay attention. The minute you try to apply that to the Earth, you still have to prove the Earth is rotating. You can't assume it. You can't presume it. You can't think that it is, right? Because you're taking something that is not attached. It's not on. An airplane, a cloud is not on the surface of the Earth. So
Travis,
therefore, hold on. I'm sorry. Therefore, ipso facto, it's not the same primary Coriolis observation.
Okay, you're. I think that you're. Okay, the reason. Okay, this is why. Let me explain this. Okay, just because it was on the surface when the original Coriolis thing was determined because of the merry-go-round or whatever. That is the first example we see of it. Okay, but the point is that a plane or a projectile, they have to say, because of the physics of a ball Earth rotating and a projectile that's moving in one straight direction, they have to say there would be a Coriolis, even though there's not. Well, you know that because we know there is a stationary, right? You and I do at least. But the reason they have to include it in the physics in the claims is because that's the way it would work with the physics of a projectile over a moving surface, right? Because it actually expounds on that. If it's on the Earth, you can even compare it to a car or something like that, and then they get away with saying, "Oh, well, you don't feel it in a car," but that's within the same reference frame because it's on the Earth. Once it's in a different reference frame, moving in a straight path over. Wait a minute. When it's moving in a straight path over a rotating surface, that whole thing gets totally exaggerated and shows that you would have to have an Earth rotating below a straight path of a north to south projectile, which is what causes the displacement.
I know. I'm sorry, Kosho. Okay, look. So we have two different things. Oh, I know, man. I'm
trying to respond to you.
Okay, so, go ahead. All right, go ahead, Kosho. Go ahead.
All right, yeah. The Coriolis, doesn't matter the demonstrations he made or observations that he did, tests he did. It's the principle of what he did, and it was to describe how objects move in reference to being on the rotating frame. So it doesn't matter if something's in the air or on the ground, or wherever it is. It just matters that the thing's rotating.
No. You just said it. You know, Kosho, you just said it. It's on the rotating surface.
Why are you saying it wouldn't?
I said it.
Why would you?
I
why
said
do you
it
think
doesn't
it wouldn't
matter
work the
if
same
it's on
with something in the air? Why do you think it doesn't work the same with something in the air?
No, I'm telling you, it does.
No, I'm asking Travis. What is it? I mean, your name's Travis, right?
No, it's me.
It's not Travis.
I'm Travis. Okay. So if we have a merry-go-round, we rotate that merry-go-round. We roll a ball across that merry-go-round. That ball's deviation is going to be physical, 100%. If you then take that same ball and throw it across that same plane, it is not going to be physically deviated the same way. Yes or no?
Well, the thing is that I'm trying to get them on it. Okay, the Coriolis effect is the same thing, whether you're rolling it or throwing it. Okay, it's just a matter of it's in physical. Well, regardless if you disagree or not, it's the same effect we're talking about. We're talking about a straight path in relation to a curved surface, regardless if it's in a plane or regardless if it's on the ground. It's actually less if it's on the ground because it's in the same reference frame and it would be bound to that Earth in a lot more physical manner, right? But you could, if it could still possibly roll straight, and then there was a curve of the spinning Earth somehow that shows that, then that's. But the thing is with the Earth, we all know that we're not seeing Coriolis when we pitch a baseball, so therefore it's not effective enough in this reference frame until you go in the air and you start going over multiple latitudes, which have different tangential speeds, and that's what I'm saying is the gotcha for us, because they have to admit that if a hot air balloons they don't have to admit, but they have to claim that if a hot air balloon goes up, the reason we don't see the Earth rotating below it from the hot air balloon is because it conserves the original speed of that latitude, right? But once a plane starts traveling over different smaller circles of latitude with different tangential speeds, lesser speeds or greater speeds, depending on which latitude it flies over, it's not going to have that matching conserved speed. They would love for us to think that because of this conservation of momentum, it's bound to that no matter how many latitudes it flies across, but it just doesn't work that way. You can have your conserved speed for your original latitude, which doesn't work anyway, because it's obviously as soon as it goes up in the air, it's in a greater circle. It wouldn't have the same tangential speed as the ground because it's higher than the ground. Regardless of that, you can give them everything they want with this argument. You can give them all the conserved speeds they want. But then once it goes over different latitudes, there's going to be an out of sync moment where the plane with a camera underneath it could literally catch a west to east rotation of the Earth with the best camera's capabilities and with the best jet's capabilities. You wouldn't need any strong capabilities. In my opinion, any plane should be able to catch the rotation of the Earth anytime it flies if it were rotating. That's what I think the truth of the matter is, if it were actually rotating. But give them the most extreme conditions, the most extreme possibilities, and they can't ever say that the Earth is always only going to look stationary from a plane. They can't claim that. They can claim it's minimal. They can claim it's negligible. They can claim it's the air winds. They can claim all these things, but they can never say it's always perfectly stationary looking from a plane, because they know the only reason that would be true is if the Earth is stationary.
Okay, so let me ask you this question, new perspective. Do you think that the physical reaction of an object transiting across a surface, if I'm on a merry-go-round and I roll a ball across that surface that's moving, do you think that is going to be the same as if I throw the ball above the surface?
No, I don't.
Okay.
But the effect is the same. It's just a difference of how much the effect, because you're going to have friction.
Okay, hold on.
It's a relation of the object moving to the rotating surface, regardless if it's on the surface or not. That's all it is.
Okay, wait. So, okay, I'm sorry. So go back and say what's not the same and what is the same.
Well, you would have friction from it rolling, right? If it was on the ground.
Yep.
And it would be within the same reference frame because it's attached to the ground through what they would like to say is gravity or whatever, right?
Yep.
But if you have a thrown ball, then its relation to the rotating frame below, there's going to be a difference, right? It's still going to be rotating below the projectile moving over the plane or on the plane, regardless. It's going to be a straight path that you're throwing it in, but from the Earth, but it's going to make a curved path according to the reference frame of the Earth rotating or the disk rotating, whatever you want to call it. Because the disc turns, it creates a curved path, but it's not just apparent. When you're talking about airplanes ending up at their destination, like if you were trying to fly from let's say New York to Miami, right? And you set your path straight. You're saying I can see Miami straight from New York, right? And I'm going to follow that straight path to Miami, and I'm not going to deviate. I'm not going to let the winds take me anywhere. I'm going to follow that path. But by the time you got to Miami, since the Earth is rotating, Miami is going to be far to your left because it rotated with the Earth if you kept that straight path. You understand?
Yeah. Let me say it
so
one more
if it keeps that straight line, the Earth is going to rotate below it. And the fact that they're claiming that the Earth rotates below it and it corrects for Coriolis, if it didn't correct and we're able to do that, however they want to say it can't, if it were able to, it would be able to actually literally capture with a camera a west to east rotation of Earth below the plane as it moves in a straight line southward. That's my point.
Okay, let me try to sum up what I'm thinking along these lines, and that is that the apparent deviation of an object moving over a moving surface is not physical. It's only apparent. So if I have an object moving across the physical surface of a rotating surface, that's physical. It's real. It deviates truly. It cannot go in a straight line because the surface below it is actually moving and it is attached to that surface. It is a real physical deviation.
Okay, can I say that I think you're misunderstanding this, Travis?
Okay.
Because
is
I think
one reference frame or two?
Yeah. Regardless of that, it does make a difference if different reference frames make a difference. But the Coriolis effect, if you're rolling that ball straight, that ball is going straight. It's not curving, right? But it just appears to curve according to the rotating surface because the surface is rotating, right? It has a curved path, therefore, right? But you can roll the ball
friction on a rolling ball, right? More friction on a rolling ball. That's what he's saying, though. He's saying actually because of
there's a difference there.
There is no actual straight line because it already is curving on the rolling on the ground, right?
Yeah, there is more of an effect there, right? There's more of
there's a net Coriolis effect, right? It's a net Coriolis because it's Coriolis minus the friction. Yeah, go ahead.
Right.
Sorry.
Right, exactly. But it's still the same effect, Travis. It's still because you're talking about moving objects on or above a rotating surface and how they would be in relation to each other. And if you could capture if the ball could capture, if the ball was thrown and it could capture what's going on below it, it would see a rotating surface below it, right? Because it's going straight and the surface below it is turning.
Yeah.
Right. So if that could be just like exaggerated to whatever degree, with the airplane and a jet flying at thousands of miles per hour with all the resistance to the wind at once, it could literally capture this rotation. And the fact that the ballers, a lot of times when they argue this, they'll run around and start saying, oh no, it would always be in sync. It would always, the winds would make it do this, and it would be affected by the winds so perfectly that it would hardly be able. They can't say it would never, but it would hardly be any difference, or it would be negligible. But just the fact that they're saying hardly or negligible or anything that amounts to anything means that there could be something to be captured with a camera showing this actual rotation. And the fact that it never happens means it's not rotating. I don't know how you can get out of that argument.
I think what they mean by negligible is that it happens so slightly because of the air pressure, right? That it's all moving together, that you wouldn't really be able to, excuse me, measure it in a plane.
There's your problem. That's your problem, though, right there. If we get back to it's rotating atmosphere, it's horseshit. Right,
it doesn't solve the problem.
It's not horseshit.
If you want to go New York to Miami, let's say for the sake of the exercise, that is due south. So if you're in a World War II P-51D Mustang with no electronics, no fancy anything, all you've got is a compass on your dashboard, and you fly due south from New York to Miami, which at 250 miles an hour could be an 8-hour flight. I don't know, 6, 7, 8 hours. The Earth must move underneath you unless you subscribe to this nonsense of the rotating atmosphere, which I'm telling you from day-to-day real-life experience is garbage. It can't happen until somebody shows me that it can.
And wouldn't you say even with the rotating atmosphere that it still doesn't solve the problem, because they would have a different conserved original speed compared to all the latitudes they're flying over, which doesn't match that as well. Speeds, right? So
that's another nuance to the argument.
Yeah.
But I'm trying to just make it really basic and simple.
Yeah.
Yeah, but the thing is,
just layers of
magic
layers and layers.
Y'all can say all that, but can you put it down on paper and demonstrate that?
Howard, I'm telling you, my brother, believe me, nobody will show you a solid object dragging a gas around, or even a fluid for that matter, like a liquid. You can't get it up to the speed of the thing which is creating the rotation. I do this, man. Believe me, it never ever happens.
I understand that you're convicted. You're convinced on that, and I don't doubt that. But I mean, the thing is, it's doing what it's doing. There is a video that I've seen where they've got this rotating body, and they put smoke in the vessel, and they pull a bubble. It's like a soap bubble, and they spin this body, and that smoke starts turning with that spinning body, and then they pop the bubble, and you can see the smoke is rotating out of that vessel. I mean, it's a demonstration of what we're talking about, and you got to consider. And I know from my perspective, maybe y'all will laugh, but the Earth's been rotating for a few billion years. It's had that long a time to do what it's doing.
But even if I grant you, which I don't, but let's say I did grant you the billions of years and I buy into that discussion, there's still going to be the greatest point of adhesion is going to be at ground level, where the gas is directly in contact with the solid object. And Rumpus said earlier with his spinning sand belt example that when you get just above the spinning sand belt, which is spinning at, who knows, 2,000 revs per minute, the friction with the air above it quickly negates the movement created by the sanding belt. So once again, I go back to, we're talking about a so-called atmosphere that's 50, 60, 70 miles high. like your own brain must be screaming at you right now that it can't happen. That doesn't make any sense in my real world.
Yeah, I would picture that there is some degree of lag with it.
Well, here's what's interesting about.
Well, but I don't have an issue with it. I really don't. Go ahead, Grimm.
Okay.
What's interesting to me about their model, the Glober model, the standard narrative, what's interesting to me about it is that for some reason, sorry, took a dab. They're kind of complacent about the fact that the higher up in the atmosphere you go, the faster the winds are actually going in the same direction that the Earth is spinning, and in some cases, in many cases, faster than the Earth is spinning. Supersonic speeds at some of the plasmas up there are spinning incredible speeds. It's ridiculous, but with their model, it doesn't add up. And you can even see the wind maps. When you look at their wind maps, the higher up in altitude you go, the more structured the wind is, and that is a sign of electrical activity that they're literally just basically trying to leave out for some reason of the model as to why it might even be the reason why the Earth speeds up and slows down in their model, which they don't have these. Why are the days going by faster? I mean, then 2021 was the fastest year on record, and nothing in their model says it should be speeding up at all. It's supposed to be slowing down and cooling off, not heating up and speeding the fuck up. So obviously, there's a mechanism there.
Winds. You know, how would you have a north or south moving wind if if it's all being dragged around in one direction?
Yeah.
Yeah, you got to have electrical currents and all kinds of stuff going on out there for all of that to happen.
Yeah, you'd have a constant 1,000-mile-an-hour westerly at the equator.
Yeah. Well, you see it's like magnetic, those magnetic anomalies.
Wind in your face constantly.
Yeah, and if it's all going in that one direction, why would it slow the plane down when it gets into that? If it's moving in the direction of the plane linearly, why would it slow the plane down to the speed of the surface? Why would it affect the plane in that way? They have to move. They have to have the winds going the opposite direction to slow it down.
Well, winds do.
So it doesn't work. But but I'm saying a jet plane that has a lot of capabilities flying in every direction it wants. It could do circles. It could fly into the jet stream, out of the jet stream. To claim that it would only be in sync with the Earth completely, so much so that it would only see a stationary Earth is just ridiculous. Even with everything they want, they can't claim that. So it's over. That ends the argument, in my opinion. That ends the debate. It is false. The model is falsifiable. Well, the model's falsifiable by that principle alone, in my opinion.
Well, I mean, I'm not. Do you know what you're looking for? How much movement do you need, and what direction? Or does it just seems like a fairly good idea, and I'll leave it at that. Hope that
I have a lot of scenarios here. Yeah, I could draw it for you. I've done it with this guy that I'm talking to online. That's a baller, and he's trying to wiggle out of the idea that the plane would only see a stationary Earth. I mean, if a plane could do whatever it wants, it could capture a rotating Earth because it's in a different reference frame. The fact that it can't do that, then that means that it has to be stationary. I don't know if there's any way of arguing against that. Unless you can go out and show the rotation and then they could prove their model, right?
I don't think the Globers claim it's a different reference frame. I think they claim Coriolis is happening in one reference frame, actually.
No, they have to claim, well, if they're honest, they have to say it's a different reference frame.
Well, then they don't understand the definition of Coriolis. It has nothing to do with conservation
or reference frames.
Momentum, which is what they always go to.
It has everything to do with conservation. The momentum on a projectile fired from the equator.
No, it has nothing to do with conservation of momentum.
Okay.
Wow. We'll just have to leave it at that then, I guess.
Well, my point is that the conservation of momentum idea really screws it up for them. In fact, not that it would be any better the other way if they didn't have that, but because something goes up in the air and we don't see the rotating Earth below it, that they can claim this conservation of momentum to keep their model But then once the conservation of momentum's kept at one latitude and it flies into a different latitude, they can't say that it matches perfectly with a 750 mile latitude, the tangential speed compared to the original conserved 1,000 miles per hour. You can say that the winds make it slow down to the 750 mile, but you can't say that it automatically is perfectly in lockstep with a rotating Earth as it goes over these different tangential speeds. Like the original conserved speed, they would love to say is conserved forever, and that's why you could fly, westward, and it would be actually moving 600 miles per hour backwards, but 200 miles per hour forwards, and all that kind of craziness. They have to say that because that's what the model would require the plane to look like from space. It would look like it's going 600 miles per hour backwards. They have to admit that, right? But then once they go across north to south in different latitudes, it's not going to match the ground speed close enough for them to claim that you would never see anything but a stationary Earth. Period.
So let me jump in and ask, did anybody hear what I heard as opposed to what new perspective explained? Like, I still feel like he and I would go back and forth on arguing, and I don't want to do that. So does anyone want to say, yeah, Travis, I totally hear what you're saying, he's not getting it, or Travis, you're not getting it, he's totally right?
Do I have to? Because I just don't want to start another fight.
Well, which
one?
one?
There's no fight. We're not fighting. I think that
I
understand. I understand what you're saying completely, Travis.
I know, but for some reason I'm not seeing, for some reason, the connection that your explanation is giving. So I'm asking someone else to come in and say, okay, Travis, what new perspective has said is what I agree with, but you're not getting it. So Grimm,
If Grimm doesn't help you out, maybe the thing I put in the live stream voice text, you could read that by the Edward Henry.
Okay.
It explains what he's talking about with airplanes and the Coriolis.
Well, I'm still trying to see how with an airplane you're moving outside of the relationship of the air pressure.
Would the air pressure always make the plane in lockstep with the Earth over different tangential speeds? So much. Well,
first of all, I
see a stationary Earth.
Yeah, you're confusing the situation. I'm trying to make it more simple, dude. First of all, I'm trying to see, do you even agree with the conservation of momentum as an actual?
Yeah, conservation of momentum is a real thing. Yes, physics is a real thing. Right. I'm not denying the laws of physics whatsoever.
No, okay. Well, I mean, okay. So if we're already on the surface of the Earth, spinning with the surface of the Earth, right? So wouldn't that in of itself, even with the air pressure that's also spinning with the surface of the Earth, wouldn't that in of itself cancel out what you would think as any other movement, because you wouldn't be able to detect it because of the conservation of momentum?
Yeah, I'm saying if we give them that and say, okay, fine, okay, if we're rotating with it, we don't feel it, we're moving with the Earth, right? But then once you go across different latitudes, north and south, it's not the same speed because the circles get
just
smaller.
Imaginary lines. You're still in the air pressure. You're still moving with the rest of the air in the same direction. Right. So there's not going to be. All you're going to really do is just measure the time it took you to get to the location with the speed.
Right, but see, that's what I'm saying. Their model fucks it all up for them because they want to say that the conserved speed you start at will always be conserved, right? And maybe the winds will slow you down a little bit, but not perfectly every single place.
The only reason those speeds are conserved, that doesn't make any sense because we're going through friction. We have to keep on hitting the gas to get through it all.
Right.
I mean, it's not like you're ever going to really conserve anything. We're not in a vacuum. You know what I mean? So for that example, for them to say that we're trying to we're going to be conserving all of our, that's like if we were a projectile. But this is an engine with, we're thrusting through this. We're hitting the gas pedals. So there's no, we're not expecting any too much conservation of in the forward direction that we're going to be going. We're going to expect.
Well, that's the point, though. My point is that a plane not only can mimic a projectile and do a dead reckoning if it wants to, right? Just like a projectile, but it goes over much longer distances. So this Coriolis effect would be much more.
What mimics a projectile about a plane? A plane is actually flying using the wind itself, fixed to the wind in its way to create a flight, a lift and a drag, a situation of a complete altering dynamics depending on which
way you about. I'm saying a straight path is a straight path, regardless if it's a projectile or not. A straight path is a straight path.
Well, that's not necessarily true, right? Because if you have a slow-moving drone that is going across a 10-mile-an-hour wind, it's going to have to compensate. But if you shoot a projectile through that same medium, it's not going to be affected.
Yeah.
Well, I know what you're saying about the speed. The speed and the size make a difference, right? Yeah, I understand that. But if you could have a drone that could fly if it was flying over a bullet and it was a badass drone, right? And it could follow the path of a bullet. Just imagine it that way, right? Then it would experience the same deviation that the bullet does. That's all I'm saying.
No, because it's actually cutting its path through the air. Design, and the bullet is a projectile. It's not flying through the air at all.
It's cutting through the air too. Yeah, I'm saying if it could mimic the actions of a projectile, it would be the projectile's cutting through the air too, right?
Okay,
and the reason that it would be, of course, is that because the rotation,
can't drive
that's the
it. You're not
Coriolis.
The projectile doesn't have any other force behind it other than the initial force it had when it left wherever it left. Right, but the drone has a continuous engine force behind it. It's not mimicking a projectile. A projectile has an engine. Has no engine.
It could mimic it. It could mimic it if it wanted to.
Okay, so look. Right. Okay, hold on, just real quick. Let me walk through this real quick. The difference between a projectile and a drone. If the drone had a substantial amount of battery power, it could stay in flight for a longer time. And so it could follow the same path for a longer time.
Right.
But the projectile is moving faster, but would have a shorter duration of air time. Right? So you can't, in my opinion, this is why I say that is the controlled flight, or I don't remember how I put it, the manned flight fallacy. You can't necessarily discount a helicopter from Coriolis because you say, oh, that's controlled flight. That's a fallacy because it's not the same. It's not the same physical reality.
Wait, Travis, let me explain. This is how they try to get out of it, though. This is what they're saying. This is how they're tricking us. They've been tricking us. This is what it all hinges on.
Let's don't act like we're all trying to trick you. Though.
No. Okay, I'm just saying that my experience with ballers that realize this is a problem and they don't want to acknowledge it. They run around trying to say, "Well, it's got an engine. It's not the same as a projectile." It makes it worse for them because I'm just saying it's over a longer period, right? The reason that they have to claim it with long distance.
It doesn't matter about this longer period stuff. You're still not basically free falling in one direction in order to get this done. You're driving your path with a fucking drone. You don't get about that? How's anybody trying to trick you?
Well, let me explain.
You've got a force pushing. You've got a force continuously pushing you forward. It's not just your own inertia, so that's how you detect that Coriolis is by just using your own inertia. You're not still being driven.
Right, I understand. But okay, do you understand that the reason that they have to claim that there's a Coriolis effect with projectiles that go over long distances rather than short distances? Like if you shoot a bullet across the room, or across the street, you're not going to expect any Coriolis deviation because it's such a short path, right?
Right. You needed more time. You needed more time to cover more distance in order for
more distance,
and more of a parabolic.
So when it goes over, and that's the problem. When it goes over different,
so many factors that you're not really paying attention to.
Let me.
No, I'm considering all those factors. I'm considering all those factors. If you were at the equator and you were shooting a projectile to the North Pole, right? By the time it got to the North Pole, if it doesn't deviate, it goes straight and it goes fast, then the Earth is going to turn below it, and it's going to land. Like if it was landing before the North Pole, it's going to land different than the original straight path to where it was aiming, right? Because the Earth turned below the projectile. That's what the Coriolis effect is. Physical rotation of the Earth below a projectile going north or south. And a plane would be affected by that and could mimic it and could go longer distances to show that effect even more.
Okay, wait. Okay, look.
It's simply a matter of, is there two reference frames or not?
Yeah, but listen. Yeah. Okay, right. Okay, look. We're at a crossroad. We're at a four-way stop, right? I'm at one corner. I'm going to shoot across to the other corner. I'm just going to make it a BB gun. I'm going to shoot it. Boom. It's going to go fast. Boom. And it's going to hit the target. If I get a drone and aim the drone at the same spot and take 3 hours to get there.
Well, if you set your gyro,
I'm talking about a jet
only
plane. There's jet planes that can fly 1,200 miles per hour. They can fly just as fast as bullets.
This is what I'm saying. Okay, look, fine. So make it 2 miles. Make it 10 miles. Make it a missile that you're going to shoot 13 miles away. Boom, you're going to hit the target. Okay, and it's going so fast, there's not going to be any Coriolis because it's going so fast. Okay, fine. Take a drone.
Won't be time, right? Won't be enough time.
Take a drone and make it go doop ba-doop 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 ba-doop, and it takes 3 days to get there. It's still going to get to the same location. You have the same effect, guys.
Yeah.
No, I agree because you're assuming a not motionless Earth.
It's driving.
But we're trying to think about it in their model how it would work.
And actually, I don't even think you know that. Right, you're just claiming that. I don't think you know that. If you set a gyro,
I do know that. I do know that.
Excuse me for a second. Actually, I don't think you do, because if you set a gyro on a drone and you set it in one direction and set it forward, and you marked out your path where you think it would be in 6 hours, and you made it not go to the path but follow the gyro only, I don't think you will be on that target from the equator to the north, or from north to the equator.
Listen. Fair enough.
No, you won't.
Okay, hold on. Hold on. Fair enough. Show me.
Well, no, you show me, because this is your thought experiment, and I'm actually almost
no, sir.
100% sure.
Travis, you said it would go in the same exact location.
Hold on,
real quick. You claimed it would go in the same location. I just said I don't think it will. Now it's your demonstration to show us that it will.
Wait. Are you guys disagreeing because you think one of you thinks the Earth's rotating and one of you doesn't? Is that why you're disagreeing?
Wait, hold on.
Of course, yeah.
Okay, hold on.
Okay, well then the thought experiment has to include whether it's a rotating Earth or not a rotating Earth in this.
Listen.
No, it does.
Hold on. Let me try to cut.
Oh my God. Okay.
I know. Sorry. Sorry. Grimm. All apologies. Let me try to cut you off the knees real quick. What you should have done to me was say, after I said what I said, you should have said, "Show me," but you didn't. You gave.
No, I'm not trying to play games. I'm not trying to play games with you and try to tie you down to the. Oh my God! You really need to finish. You're in slow motion.
You're talking past each other. You're talking past each other because you're not. You're misunderstanding Travis. He's saying show me because it would have to be a real situation. You're saying it would hit the same target because you know the Earth is not rotating. You because the Earth is stationary, it would hit the same target, right? But he's saying if it's a ball Earth rotating, it wouldn't because of the Coriolis effect. Am I right?
Exactly. Right. But Travis is making a positive claim, and the burden of proof is on that positive claim because Grimm is contending it.
That's all.
Yeah, but they have two different. The thought experiment.
And I'm saying I don't think it would. So demonstrate that it will.
The point is, if the gases.
All I'm saying is I don't think it would if you actually use the gyro as your directional and not your location or GPS, because that's the only way in my book you're going to find the same spot. Otherwise, you're going to be off target. And if you just use the gyro, and I'm saying that I believe that that's the case, that what you're saying is not true, and that I would need you to demonstrate that to show me that it's true.
Wait, on that point, Grimm, real quick then. You're saying that the reason it wouldn't hit the target is because the Earth is moved below it, right?
Right. Coriolis.
Right. Yeah. So then my whole point about the camera on the bottom of that drone would show a rotating Earth below it.
Yeah, that would be a great experiment right there. If it's following the gyro heading, like Grimm's talking about, that it would fly directly due north, 0 degrees due north.
That's my point.
Over a period of time. The further north you go, the more diagonal the ground track will be.
Yeah, and you should be able to falsify the models just with that alone. Just put a camera underneath the plane, have it go dead reckoning north or south. That's it.
Yeah, but the plane's not going to.
It's not dead reckoning. It's not going to go dead reckoning north or south. What's happening is you're going to go in one direction, tied it to the gyro, so it's not allowed to deviate either way. I don't care which way you shoot it, except for east to west.
Yeah, don't say dead reckoning north or south, because if you have north in your bearing, then even if the Earth is slowly rotating, it'll be accounting for that as it maintains its northern bearing.
Yeah, dead reckoning north-northeast would be better, right? Because then you're going at an angle and it would go across
if it's conserving its momentum and following the gyro, that drone is going from the equator flying due north. It's going to deflect to the east.
Correct.
And
of course, the point is don't use a compass. Like, you use compass, you're fucked.
Yeah.
Or use a gyroscopic bearing, you're fucked.
Like the ballers claim, if they're talking about like, oh, well, if I was going, true west, they call it, right? If they went true west, then they would end up in Antarctica possibly, or outside of the circle if they didn't use their compass, right? So in the same logic, if you were able to go north or south in a straight line and not let yourself go with the Coriolis curve, conserved speed of the Earth to make your deviated path and end up where you want to be, and you just go straight, then you would literally be able to show the Earth turning below it with a camera if it was moving. But because we never see that, it's not moving.
If the atmosphere of the gases is not moving in lockstep with the Earth, then they're separate reference frames. But they claim that they are. So
yeah, that's our model. Yes, that's the rotating Earth model. Says that the atmosphere is rotating with the Earth.
And it still doesn't work in your favor when you're talking about long distance flights, because the Earth would have to move below the plane. That doesn't correct.
Our model also says that Coriolis is insignificant to flight.
Right, exactly. You eliminate the negative. Yeah. Right. Listen, Howard, listen to what you just said. You eliminate all of the obstacles. You say, this is what's happening, but we eliminate everything that negates it so that it works out the way we say. No. Come on, man.
It has to work that way for them to have the model.
It's there, but we don't see it because blah, blah, blah.
Yeah, it's ridiculous, dude. It's insane.
Here we go. We're going to have to put a drone in a vacuum.
We don't see what we should see.
Yeah. That was good, Grimm. That was good.
We don't see what we should see, but that's because of blah, blah, blah.
Oh, my God.
It's hilarious to hear him just run around it, and like, or to think of it just as an apparent motion rather than an actual displacement. There's a physical displacement that would go on if it didn't correct for Coriolis.
We've talked airplanes and Coriolis into the ground. That's been explained in great painstaking detail, and it's not an obfuscation or an easy out for us. It's just the way it is.
So let me ask you this then: if you've talked it into the ground, is your conclusion with your model that a plane that doesn't correct for Coriolis would never ever see anything but a stationary Earth?
Do what?
In your model, are you saying that your model works in the way that a plane flying north to south never sees anything but a stationary Earth below it, no matter what?
That might be a way to measure the net.
How could that be? It doesn't even work out with the math.
Well, it's insignificant to the plane, and you'll see that these NASA documents and things that say this document considers a stationary non-rotating Earth because it's significant.
It wouldn't be as insignificant as the point, though. And even if it was something, even if you're saying insignificant, you're saying there's something. And because there's something, you would be able to capture it. But then they want to, at least maybe not you, but other ballers will say, yeah, it's something, but you can't ever see it. So, like, what are you trying to say? It is something, but it isn't something? It either is something or it isn't.
I don't know if anybody says you can't ever see it, because I don't think it's used for those kind of larger things as much. I think, but it might be detrimental to making a shot at 500-600 yards.
No, it's the longer distances that it makes a difference, Grimm.
No, our position is there are other forces.
500-600 yards is pretty far.
Well, 400 yards in a plane.
The ball spinning. That's not minuscule amount. 460 meters per second.
Yeah, exactly.
Well, as far as the planes go, our argument is there are other forces that are far greater than the Coriolis affecting the plane.
Ones you can't see or measure.
Relative to something else, right?
I mean, that's just what it is.
Well, the lift and the drag itself.
Yeah.
Well, I'm just talking about like a jet plane, because we have these jet planes, like the one, the F-35B. It can fly 1,200 miles per hour. It can hover with 40,000 pounds of thrust. It can do whatever it wants in the air. It's not like the atmosphere is making this plane do anything that it doesn't want to do, right? Even if the winds were perfect.
We don't expect it to.
It can free fall. It can free fall. Yeah, sure. You can do whatever it wants. We know planes can do whatever they want in the air, right? They can fly against the spin. They can fly and due west and not use a compass. They can do whatever they want. So therefore, it could show the Earth rotating if the Earth is rotating. That's all. I'm repeating myself too much.
You're trying really hard, and that's nothing wrong with it.
Well, I'm just saying this. It seems ridiculous to argue that it would never be that a plane could only see a stationary Earth.
The best way to make a plane, detect that type of motion is to get a really, really long tower, take a cable, hang the plane from the cable, and swing it like a Foucault pendulum.
Yeah.
You just use a Foucault pendulum.
The point that the flat earthers would like to make about all this is that the Foucault pendulum and the Cavendish and all these drifting examples, even if we have winds that are going in easterly or westerly directions and one side or the other of the plane, this could be all caused by this toroidal field or ether or whatever else it is besides the rotating Earth. And the claim that it's the rotating Earth doing it is the problem. And the plane could very well show if it's rotating or not. And we can get over that problem and move on to figuring out why there's these drifting things going on and the cause of those things, rather than just claiming it's Earth rotation and be done with it. Just falsify that Earth rotation with the plane, which should be very easy to do. And we can get on to figuring things out instead of arguing these points back and forth with people that are just claiming things that couldn't possibly be so.
So what's your opinion on hurricanes rotating?
I think there's some kind of a magnetic toroidal field direction going on with the rotating stars. It's all connected in one system. I don't know the reason that things move one way or another exactly, but I don't think it's because the Earth's rotating. So we have to figure that out, right? I think that a lot of these people were helping try to figure out at least what could be another solution, rather than saying it has to be Earth rotating and just focusing on that. When that seems like a dead end, even if they want to believe that still, they could at least use some thought exercises to try to at least entertain some of these other possibilities. But are we all on the same page trying to figure it out, or are we just trying to claim a model?
Yeah, but from the globe model, it's explained. It's not a question.
Not with the planes and the Coriolis. The planes don't ever see Coriolis, then that falsifies the model.
But the hurricanes do.
Yeah, that's what I'm saying. It's a different thing, right? There's some different effect that's affecting the hurricanes, and you can't conflate it with Earth rotation.
Yeah, the interesting thing about hurricanes is they're highly electric.
Yeah.
And we do know that those plasma formations do occur in nature now. They found them. They're called plasma hurricanes. They're found over the North Pole in 2014, and they didn't announce it until last year or this year.
Oh, Grimm, I got to send you a video that I just saw about plasma. I'll send it to you.
And that they're going to learn, and I'm pretty sure it's going to not be too long from now. That these electrical storms, these storms are electrical by nature, and they're not caused like from the inside out. They're caused from the outside in, and the space weather has a lot to do with it. So it's a new frontier. And the fucking poor standard narrative guys hate it because they were just telling me a few years ago how I was so stupid and how there was no merit to the electric universe and never find any evidence to support it and all this kind of stuff. Just really tried to hammer me home. And I thought, these guys.
Well, that's what's awesome about it, because we know plasma physics is the next frontier, right? For sure. And there's like, people aren't waiting for the people that are holding the Coriolis, or not the Coriolis, the heliocentric model. They're in the positions of their academic positions are solid. They have to die off before maybe some of these things should move to the forefront in the higher up.
I think some of them are dying. Right? I think some of them are dying or something because they just flipped the whole script on how stars work. Remember, it was nuclear reactions going on inside of the star. It was down inside the star deep in these really super hot things. Well, none of their models can ever produce any of the shit they're saying, right? Nothing's working out. And what they have done, though, is these stupid ass idiots, at the Sapphire Project and they demonstrated the transmutation of elements and the fission and the very low temperatures and low pressure hydrogen discharge experiments. And they got the nuclear energy out of it. They got all, they're not overage in a way you would think of it, more capacitance, where a small amount of current is put in for a particular amount of time, and then the internal plasmoid collects that power and then discharges it in huge amounts of energy. It's really crazy.
Hey, what's your take on the solar minimum ideas, or anybody's on this grand solar minimum that they've talked about for a while now?
Well, I'm a fan of suspicious observers. Ben Davis, I like his work, and
does he talk about that?
He talks about and so does a channel called the Grand Solar Minimum. They kind of focus on that.
What do you think they're predicting? Are they saying soon, or we're entering it now, or what's the prediction?
Well, we're going into the Grand Solar Minimum.
Just quick,
but that doesn't mean that the sun is going to give us less electricity. It's not. It's brightness and electricity aren't always the current that we're getting aren't always the the intensity isn't always the measurement of the heat we're going to get, because a lot of those interactions are electrical that give us that heat.
Yeah. Like my understanding of it is because it's powering down to a certain extent, it's going to go through its next cycle or something. And because it's powering down, the electromagnetic field weakens. So therefore, it actually gets hotter in some areas because the field is weakened with the protection, right? So it's getting hotter in some areas and colder in other areas.
Yeah, it's crossing itself exactly about to flip. And that crossing creates a friction, though, which would cause intense areas of heat with lacking the opposite, depressions, magnetic anomalies that would cause cold.
Right. So are we headed for it? Like, do you think you're going to have some ice ages coming up, or what?
Well, I mean, we're probably not so much, right? Aren't we still like coming right out of one?
Are we? I don't know. I thought we were headed towards 11 years of ice age type stuff, according to some people. No. Okay.
That's just hyper. I think that's I think a lot of times what seems more likely is that when the polar flip does occur, if this is a magnetic and electromagnetic system like it is, then what we're seeing are signs of the poles about to flip again, not just on Earth, but the sun itself as it passes over the center of the Milky Way. Because it goes in a sheath, like in a wave, like if you imagine like a sheet getting waved, and in front of you, and you imagine like a straight line in between that, you see what it looks like, sine waves or oscillations on a oscilloscope or whatever. Right. Imagine that though, and that's the I guess the electric sheath, the Alphean waves of the Milky Way, and they've been mapped out, the magnetic structure of them and everything. So they do exist, they're there. And the sun is riding up and down on those, right? As it goes up, it's about to cross the magnetic ecliptic, that ecliptic plane of the magnetic field, which will flip the sun. The sun will flip, and the poles will, a current coming in will come in from the other side, and it will do opposite. And so there could be some sporadic shit going on at that time. Like,
is that like a plasma event type thing?
Right. That's when we see double layers in a laboratory. When this happens, we see double layers explode, and it would look like maybe let's say a mini nova or a micronova or something, where the outside shell of the sun, instead of just like CMEs and shit, we're talking a full on deshelling the sun and rebuilding a new shell over a very short amount of time. So a super amount of intensity and flashing can go on, where it would literally microwave whatever side of the fucking earth that is rotating into it at that time. And
or at least below it, regardless if it rotates into it, at least that it's it could be over a plane too and work the same way, right?
Well, it hits the South Pole first, right? Maybe that's why the South Pole is less populated, the southern hemisphere or whatever. If this globe thing is real, I'm just saying from that axiom, but
right.
know, it's less, it could, I just don't know enough to really get into it too deeply, but
have you ever heard of Jasla 111 has like the model of the sun moving over like a figure 8 path, where if like say that they just cut the ball in half, right, and put the two circles side by side, and then as it crosses the celestial equator, it goes around in a figure 8 and then comes back around. I'll put the video in the live stream.
Yeah, I already.
He has it worked out with the time streams.
I made that map up, bro. I made that map.
Did you? You had the same idea?
Yeah, well, I had 2 domes, and I called it the Booby Dome Earth. I was talking about that 6 years ago.
I called myself a titty earther. Yeah. I was like, I'm a titty earther, man. That's the way it has to work.
I'm going to the North Tassel or the Southern Tassel.
It works. Yeah, that makes more sense because we're not moving.
And then I put videos about MRT. See, I haven't not been helpful to flat earthers. At least I play around and try and all that kind of stuff.
But if you're like open to at least brainstorming.
I pulled out some MR Mr. Too Tough 2, right? He's a YouTuber, right? Who deals. He's an electrician and he plays with high voltage and stuff. And he has a video. It's called Electric Coriolis Effect. And if anybody's interested, just quickly search that for YouTube, share it with everybody and all that. And he shows some interesting stuff. Mr. 2, number 2, Tough, TUFF, and then the number 2 one more time. Mr. 2 Tough 2.
Okay. Electric Coriolis. There we go, guys. We're getting to.
And
I think the electric
really
flat Earth is the way to go.
This video is fun because he can demonstrate in the aquarium the rotation from ionization to non-ionized particles as they become ionized. As they're non-ionized, they become attracted to the electric field, and the magnetic field keeps them rotating with the electric field and the magnetic field operating together, obviously, because one doesn't exist without the other. So have fun, watch that.
I'm looking for it. It doesn't come up right away.
Out of it. Oh, maybe I can find it faster.
I'm sending you a video, so you can just reply with that.
All right.
There's this channel called Divergent. This guy is pretty cool. He does really quick videos, gets a lot of information in there. Talks a lot about like the resets and Tartaria maybe missing the point, but getting closer to it.
It's right here. Magnetohydrodynamics, the electric Coriolis effect.
All right, I just sent you a video. If you want to just send it back to me, then I can.
Sorry, I'll grab it. Yeah.
LC King does a lot of good work. You heard of him before? With the electric flat Earth type ideas. You want his?
No, I really don't. To be honest, I might know what the work is, but I don't usually remember people's names if I
right.
favor what they were doing.
I mean, it's obviously an electric Earth, regardless if it's flat or ball. It has to be. We are electric beings. That everything works that way.
It's not on purpose. It's just a subconscious thing, right? You know, if you're really excited to talk to somebody, you remember their name more usually. So, but
yeah. Exactly. Right, yeah. I sent you one of his. All right, I've talked a lot.
I appreciate that, man. Hell yeah.
I appreciate your comments as well. It's just interesting, the subject. Yeah, I'm gonna head off a little bit and let other people talk. But yeah, cool.
Usually when they want to talk, they just do. Like there's not Aruga.
Yeah. I remember listening to you back in the day with Issa and that thing that he always brings up about the principal, the movie The Principal.
I know. Oh, were you there for the actual time?
Yeah, I was there.
So
I was live. I was there that day. I was laughing my ass off.
I was so
you were like, isn't that
first.
with what's his name? Isn't it with
I thought it was like
Jim
Belushi,
Jim Belushi or somebody? Jim Belushi
with the
movie,
bat,
right?
Jim Belushi.
Yeah.
Like it was called The Teacher or something, and there was a movie.
No, there was a movie called The Principal, but
right?
that's a different.
Okay.
Yeah, but it's not The Principal about the electromagnetic background or the microwave
that's what
background.
Happened. I literally just walked into the room when he asked me that question, right? So I had no idea the context of the question. All I had was like, "Hey, you know The Principal?" I was like, "Oh, that movie, Jim Belushi." It was so
Jim
natural.
Belushi,
yeah.
Why did they put that out? That's the weird thing. What were they? Where are they headed? They had to like backtrack it and take it off. You know, like maybe it was just a step too far. But it seemed like they put that out there. You know, with all these different, headline names and everything, as if they were trying to make some, new cosmology that people could see was now we're going geocentric at least, right? They were trying to go geocentric with that.
Oh,
and then they had to like backtrack.
Oh yeah.
Yeah. But then, it was just weird that it came out.
What is this microwave background? I still think that they just are so confused about this microwave background radiation. It's literally like Pierre.
Yeah. How does electric universe explain that?
Well, Pierre Robitaille says that this is the ocean's emissivity, and it's got absorption to microwaves, and it takes a while for them to be re-released, and that it has all to do with that in the oceans of the earth, and on those
in the sensor or whatever, the station was like the station was like 5 kilometers or something like that from the shore and stuff.
Yeah, exactly. You watched that shit too, and then it was interesting because he made a video about farewell or rest in peace to this particular thing that they could, the